So today what I will show you, I will show you one project, so which is some text summarization. I think you saw these kinds of online application, right, guys? Did you saw? Suppose if I give something here, let me copy some of the text from somewhere. Hagi half guide. Let's copy this text, okay? And if I go to this website and if I paste here, now here actually you can summarize them, okay? Because see, this is kinds of bigger paragraph. But what I want to do, I want to like make a summarizer so that this text can be like you can say I mean, you can convert this text to a smaller summarize so that people can get to know what is this all about. Because I don't have that much of time to go through the story and read each and everything. Okay, so this is one of the application, like very much I mean popular application you can talk about in the field of like NLP. Okay, not only summarization, you can see plagiarism checker is also there, grammar checker is also there, paraphraser is also there. Okay, so these are the tasks actually you are also using in your day-to-day life. If you are using Grammarly also, so Grammarly is using also this kinds of NLP. Okay, so now if I click on summarize, now here if you see some text you got, okay, now if you just read this text, so you will like feel like, okay, so what are the things you can read from here? Everything would be like you can say represented by just 2 to 3 lines of like text. Okay, so this is called summarization. Okay, we'll get entire summarize of the story, okay, here. And suppose here if you see there are some summary length is also there in backend. Actually there are some you can say uh, I mean penalty value is also there. Okay, so if you just increase that, suppose if I increase to long, so now if I click on second time, now you'll see it will generate text like more than like previous. Okay, it has generated. See, if you just increase them again, click here, see it's increasing. Okay, that's how you can set the penalty also, like how much penalty you need, okay, to represent this entire summarize. I will also show you like how it has been set and everything. Okay, so I will show you these projects. So we'll be creating our own summarizer, text summarizer using transformer based model today. This is the today's agenda. I think it is clear, all of you. Can I start? Okay. Yeah, you can talk about like the key information from this entire text. Okay, suppose I think you are getting like, suppose you watched our entire movies. Okay, but now if I ask you like what was the movie all about, what was the story of the movie, so you will tell me as a story, like, right, like in 2 to 3 minutes. I don't have to watch the entire movie. Okay, so that's how actually you can consider. It will extract the key information, okay, from this entire text, and it will like provide me one summary on top of that. Mahima, got it? Like if you open any research paper, okay, in the abstract section actually we'll get the entire summary of the paper, like what is the paper all about, okay, what are the tasks they have included. So if you just reading the abstraction, so you can get the idea what is this paper all about. So you don't have to go to the methodology unless and until you don't want to deep dive in that. Okay, so yeah. Okay, so now let's start. So today the data set I will be using, so you can see, I think I'm giving you the link. So the data set name is like Samsung data. Okay, and what is this data all about? Here if you see, it has 3 columns. The first column is like ID. So this is basically, you can talk about unique IDs, okay, with each and every rows. And there you will see another column which is dialogues. Okay, so this is the dialogues. So dialogues you can relate. If I show you this one, so this is your entire dialogue. Okay, and based on the dialogue you got some of the summary. Okay, so here this is the summary, that means this is the label. So this data has been like labeled manually, okay, by the linguistic experts. So what they did, if you just read the summary of the data, so the Samsung dataset contains about 16K messenger like conversation. Okay, like you do day-to-day conversation with your friends and family in the messenger, or you can say WhatsApp. So these kinds of text actually they have collected conversational text, they have collected, and with respect to that they have labeled it. Okay, if you see conversational word created and written down by the linguistic fluent in English. Okay, so this has been actually labeled by the linguistic experts. So what they did, they like read this entire story. Okay, based on that, what should be the summary, actual summary. Okay, they have like written down here. And here you will see, here you have 16,000 example. Okay, 16,000 rows. So you can talk about, it's a little bit bigger data set. Okay, so this data set actually we'll be using for today's task. Okay, now what you need to do if you want to build this kinds of summarization system, like based on your requirements. Suppose you have some other data, you have your official data, conversational data. Okay, you can collect the data as a dialogue, then try to like label the data as a summary here. Okay, manually. Okay, because I need to provide the X and Y output. Okay, this is the X and this is the Y output. Based on that, my model will be learning like how to generate the summary. Okay, so I think you got it. The data set, is it clear, guys? The data set, can you understand? Yes or no? Okay, so here if you see, like you have training example almost for 14,732, and validation 818, and test you have 819. Yes, I will show you like how to download this data set. Okay, don't worry. So either you can download from here, it is also possible, just you need to click somewhere, but the easiest option I will show you using like Hugging Face API. Okay, I think you remember if you join the NER project, so there I used a data loader like class, right? Inside that I will just provide this name, it will automatically download the data, because this is the Hugging Face. Okay, and you are, if you're using transformer is just nothing but it's like Hugging Face library you are using. So try to always use Hugging Face if you're working under NLP, because it is like one of the best organization in the field of NLP, and it provides like so many of APIs and so many of like you can say functionality. So you don't have to worry about anything. You will get everything here. If you need any models, just click on the models. Okay, let's click on the models. I think this was my data. Let's go here. Click on the models. Now you can select the task like what you want to do. Suppose today I want to do text summarization. See, there is a summarization. Just click here. Okay, now you can select the library, which library you want to use. So it supports like uh, I think yeah. See, 33 like you can say framework. Okay, like PyTorch, TensorFlow, JAX, then like many you can see scikit-learn also. But we don't use, okay, we don't use in the field of deep learning. We are familiar with the PyTorch and TensorFlow. Okay, so what I will do, I will just select PyTorch from here. Okay, if you want to select TensorFlow, it is also okay, you can also select, no issue. Now language, okay, I will select English because I want to perform with the English language. Okay, dataset, which dataset you want to use, okay, you can select. Okay, let's keep it everything. Now here these are your model actually. If you see, okay, text summarization model, it is already pre-trained model. Okay, either you can use that model as it is, or if you have some custom data, suppose today I am using this data, Samsung data. Okay, but if you see in this data set, this Samsung data is not present. Okay, they haven't used the Samsung data to train this these are the model. Okay, so if I want to do the inferencing using this model, you won't be getting getting that much of good accuracy. Okay, so for that, what you need to do, you need to pre-train that model. Okay, I think you learned how to download pre-train weights and how to do the custom training, right? We call it like you can say uh, pre-training in like you can say in the field of deep learning. Okay, so what I will do, I will use one of the model. Yeah, transfer learning you can talk about. So I will use one like text summarization model, okay, from here, and I will like do the fine tuning. Okay, you can talk about transfer learning. I will be applying something called, okay. Now which model I will be using today? So let me show you the model also here, how to find the model. It depends upon like your choice. So I will be using today one model, which is the name of the model is you can search here Google Google/Pegasus, I think. Pegasus there. Sorry, Pegasus. Yeah, this one. Google /Pegasus CNN Daily Mail. Okay, this model I will be using today. Okay, and if you just read here, this is one of the like you can say summarization model you can talk about, and they have hosted also one API. So they have given some of the like dummy text you can compute, okay, with their website also. See, it will give you the summary and all. Okay, this is the summary. So if you just read here, you will get, it is one of the like you can say summarization model somewhere. I think they have written. Okay, you can go with that. That's actually based on your requirement. You can search anything. Okay, if you need any model, if you need any data set, you can search from here. Okay, so now let's create one notebook and let's start with. So let me create one notebook. So let's name it summarization. Okay, summarization, what I can give like using transformers model. Okay, so I'm sharing the link with you also. So make sure you have selected GPU. I will take higher RAM because again, there are lots of data. So I need higher RAMs because here you will observe like if you saw like your NER training, it was quite fast. Okay, but here it will take time. Okay, because again, you are doing kinds of summarization task. You are not doing classification and you have a lots of data here. Okay. So now, first of all, what you need to do, you need to do some installation. So let's connect the notebook. Okay, it is connected. Now, let's install some of the required packages. I think you know we need to install transformers dataset. Okay. Then today I will be using the matrix called row score. Okay. So it is used in the task of summarization. Okay. If you are doing text summarization, so this matrix is required. We call it row score. Okay. So don't go with the theory, how it works. Just remember like you need to use this row score. Okay. Yes, you need to choose GPU. Okay. If you are working in deep learning, always just select GPU during training. And today you will feel like why we don't create like training pipeline, okay, uh, in our local, because here you will see it will take a lots of time to train, okay, and you need a good resources to train, okay. So that's why I told you we train our like NLP model in like cloud, or you can say anywhere, and try to download the model and we use it as like, okay, we do the inferencing in our local, because training NLP model is like very much challenging still, like, because if you see these model are like very bigger, millions of parameters are there. So that is why. So installation is done. Now let's see which GPU we got. So you can write down this command, NVIDIA SMI. So I got Tesla T4. Okay. So now you need to import some of the libraries. I already written down the code. I will just copy paste because otherwise it will take time. So I need transformers. Okay. From transformers, I need pipeline, because whenever you will be doing inferencing, you need to call pipeline. Okay. Inside pipeline, you'll be mentioning what are the tasks you need to perform. Okay. Then this thing, I think it's not required. You can delete seed, set seed, because uh, see, all the packages you don't need here, NLTK, okay, then sentence tokenization you don't need, so you can remove some of them, whichever you are feel like it's not required, okay. But just for the quick purpose, I referred their documentation and I copied these are the packages, okay. That's why. Now let's run. See, industry grade, if you see in industry, uh if I talk about NLP, okay, they don't train the model. Okay. Most of the time, like they won't be training the model. They will be using like some paid APIs and all. But if you are doing some of the like, you can talk about experiment, or if you want to gain some of the information about your company, at that time you will be doing these are the thing, okay, in a good instance, like this kinds of cloud instance. At least you will play with the data, okay. That's how. But CB, I think you will be training, and CB projects, I think first of all, you need to get the data, then resize the data. Because see, CB algorithm training, like it is that not that much of difficult. Okay, if you are using YOLO detect on two, I already showed you. Okay, it is like very lightweight. Okay, so it is also possible like training, uh, like you can say a computer vision model in CPU also. It is also possible using YOLO V5, YOLO V6, because these are very lighter model. But here, if you see in NLP, it's not possible. There you have millions of parameter, and text data is like complex. I already showed you why it is complex, because it is sequential data. And again, whenever you are doing the tokenization, okay, again, it's like increasing the dimension. Okay, Samip, I think you are getting. But if you are creating some like lower level NLP projects, like using machine learning, at that time you can create the pipeline, training pipeline, like data ingestion, data validation, data transformation. Yes, retraining is also possible. Suppose if you are getting some new data, your model is I mean, giving the like less accuracy, at that time you can do the retraining. You can set one threshold. Based on that, you can trigger the pipeline. Okay. Again, it comes into like ML ops. Okay, there you need some tools. I think DVC you have learned, right? DVC, ML flow. You can integrate with that. You can track the parameter. I think Sani sir has discussed these are the thing, right? DVC, ML flow. So whatever things you are learning, try to integrate that. Okay, that's how actually you will be creating end-to-end projects. And everywhere, these are the thing is not required. Okay, it's not like that. Every project you will be integrating DVC, ML flow. It's not required. Now let's set our device. So here what I'm doing, I'm telling torch dot CUDA is available. Okay, if it is available, give CUDA, otherwise it's like give CPU. Basically what it is doing, it will check I have selected GPU or not. Okay, whether I have GPU in my machine or not. Okay, if I have GPU enabled, it will give me CUDA. Okay, that means it will activate the GPU, otherwise it will run on CPU. Okay, so this is the code all about. Now if I run and if I show you the device, okay, here you will see it will give me CUDA because I have already selected GPU. Okay, but if you haven't selected, you will get CPU. Okay, so this is the PyTorch code. Now let's now what I need to do, guys. Can anybody tell me? Uh, I think if you learn from any year, you need to initialize your tokenizer because every like you can say transformer model has their own tokenizer. Okay, so which model I am using? First of all, let's define the model checkpoint path. So this is the model I am using: Google, Pegasus, CNN, Daily Mail. This is the model name, and I think I already showed you here, I think somewhere. Yeah, so this is the model. Just copy the name and just paste it here. Okay, paste it here, this name. If you're using other model, you need to give other model. Okay, now first of all, I need to initialize my tokenizer. Okay, so this is the tokenizer. So I have imported auto tokenizer here. If you see inside auto tokenizer, there is a method called from pre-train. There actually I am passing the name. Okay, so what it will do, it will automatically go to the Hugging Face here. It will download the tokenizer from here. Okay, so here you don't need to download it manually. So that is the power of this Hugging Face, you can say, library. Okay, so now let's execute. See, it's downloading. Okay, it's done. Now let's also initialize our model. Okay, our Pegasus model. So for that, I will define one variable called model Pegasus, and here auto model for sec to sec. Okay, so guys, I think you remember I told you have various kinds of architecture: sequence to sequence, okay, sequence to you can say vector. Okay, this kinds of architecture you have. So here what you are doing, actually, if you see here, you are generating some sequence also by the sequence. Okay, so here you have to use sec to sec model. So that is why I'm calling this one. If you see auto model for sec to sec lm, okay, this class you need to call. So here I have imported this one, if you see, from transformers. Okay, and here the similar wise you need to call from pre-train and you need to pass the model path. Okay, that means this is the name of my model. So it will go here, it will download the model from the Hugging Face. So yeah, now what you are doing, you are giving two device. Okay, two device means actually which device you want to use to load the model, okay, during training. So here basically if you see, I have already initialized my device and it is CUDA. Okay, so it is automatically set, it will set the CUDA, okay, with the like you can say model. So during training it will automatically select GPU, okay, for the training. But if you are not giving the device, so what will happen? By default it will look for, okay, it's not like that it will use CPU, but it is the good practice. Whenever you are initialize the model, try to give two device. Okay, so basically you are setting the GPU here. Okay, now let's run it. Now you'll see it will also download the model from the Hugging Face. See, the model size is 2.28 GB. Okay, and if I talk about computer vision model, object detection model, you will see like it's very less. Anybody know what is the size of YOLO model? YOLO, like I think there is a model YOLO SPT, I think. Do you know what is the size? Did you ever check the size? Yeah, it's around, yeah, Even I think I don't have, I think I have one code. Let's see. Base.pt, right? So if I go to the properties, it's 14 MB, guys. Okay. So it's the small size model, so that's it's 14. But if you're going like larger model, so it would be around 20 to 200 to 300 MB around. Okay. But in NLP, just see the model size. It's 2.28 GB. Okay. And it has millions of parameters because it is using transformers architecture in the backend. And I think if you have learned transformers, I think you know, okay, why the model size is bigger. Because it will just use one in one cell, it will use like thousands of transformer architecture. Okay. So it's done. Now what I will do, let's load our data. Load data. So here you can call load data. Okay. And just provide the name of the data. I'm using some data. This is the data. Okay. Just copy the name and pass here. Okay. Load dataset I have already imported, if you see. Okay. Now if I execute, you can also visualize. You will get something called dictionary. Okay. Dictionary objects. Okay. So this is the dictionary. By default, I already told you, Hugging Face, they have like organized, these are the thing. Instantly it won't load the data in your memory. Instead, what it will give you, it will give you dictionary. Okay. Dictionary objects. And from these dictionary objects, you can take your data, okay, by using index. Okay. Because what will happen, because it is a huge data. Okay. And if you just load it, okay, instantly in your memory, what will happen, you will get memory error. So just loading, if you lose your memory, so during training you will be getting the memory. Okay. So this is one of the like optimized solution they have done. Okay. So now if you want to see how many examples you have, so just run this one. So here basically what I am doing, this is my data set Samsung. Okay. It has the dictionary, and for the what I'm doing, I'm looping through. Okay. That means it will give me first of all train, test, and validation. Okay. And here if you see, okay, I'm passing inside that, because this is the dictionary, I'm passing the key. First of all, I'm giving the train, test, and validation. Okay. Then I'm checking the length of it. Okay. And it will provide all the length, like number of rows, and number of rows. Okay. Now let's run. Let me show you. See, so in training you have 14,732, and test you have 819, and validation you have 818 examples. Okay. You can see. Now, if you want to see the columns, it is also possible. Let's print the columns. What are the columns you have here? So you have basically 3 columns: ID, dialogue, and summary. Okay. If you see the data, ID, dialogue, and summary. Okay. So what I'm doing, I'm just calling my data set, this one. I'm just passing the train objects, and I'm checking the columns names. Okay. And it will provide you all the columns. Now, if you want to see any example, let's see our first example, or you can say second example. If you have, I'm counting from 0. So I'm taking the first example. Okay. First of all, I'm printing the dialogues. Okay. That means this one, I'm printing the dialogues And after that, I'm printing the summary of the dialogues. Okay. If you see, I'm taking the first rows here. And here I'm calling the dialogues because here, if you see, uh, you have dialogues columns and you have summaries columns. Okay. I'm just calling one by one. Now let's print. See, this is the first dialogues and this is the summary of the dialogue. Okay. It is the manually labeled. Okay. They have done the manual labeled here. So if you just see, this is the conversation actually. So Eric, machine, Rob, that's so great. Eric, I know, and shows how Americans see the Russia. Okay, and if you see, this is the summary. Eric and Rob are going to watch stand up on YouTube. Okay, so basically they're planning to watch one movies. Okay, so this is the conversation is going on between them, and this is the actual summary of it. Okay, guys, I think it is clear how the data set is arranged. Yes or no? Okay. All right. Now, first of all, let's evaluate Pegasus on the Samsung data. Okay, let's see how it performs. Okay. So let me comment out here. Evaluating Pegasus on Samsung. Okay. So first of all, let's take one dialogue. So I'm taking the first dialogue. Okay, first dialogue. If you see, if I run the test, okay, so what it will return? It will return all the test, but what I need, I want the first example. So that's why I'm putting 0 here. So it will give me the dialogue, IDs and summary. But what I want, I only need dialogue, okay? Because summary would be generated by my model if I am doing the inferencing using the trained model. Because I haven't trained the model, I'm using the pre-trained weights, okay? As of now, just consider. First of all, I want to see whether this model is sufficient for me or not. This model I have initialized here, okay? I have downloaded from the Hugging Face, this model. It is sufficient for my task or not? I want to first of all see. So basically what you want to do, so suppose if you're doing any task, first of all, don't train your model. Try to use the pre-trained weights first of all. Try to see the output. If it is doing good, don't train your model because training is costly here. Okay. But if it is not performing good, then just go with the fine tuning. Okay. So that is why, first of all, I want to check my model is performing good or not. Okay, so that is why let's test on one data. So from this, what I need dialog. So let's copy the dialog key and pass here. So it will return you the dialog. Okay, and you can store this one in a variable called dialog. Okay, so this is my dialog basically. Okay, now if you want to do inferencing, so I think you remember you need to call pipeline. This is the code. You need to call pipeline. Pipeline I have imported here. What is pipeline? I think somewhere I've imported pipeline. Yeah, so pipeline. And inside pipeline, you need to mention which task you want to perform. You need to give summarization. And I think if you remember in our previous projects, I was giving NER. Okay, because that time I want to perform NER. So your Hugging Face API will automatically know you want to perform summarization task. Okay, and it will initialize all the configuration with respect to that only. Okay, and here you need to pass the model checkpoints, which model you want to use. So here I haven't trained my model. I will be using the pre-trained model, whichever I have downloaded here. So this is the objects model Pegasus. Okay. So this model I have just passed here, model checkpoint as a model checkpoint. If you see, so I have given the name. If you just provide the name also, it's fine. Okay. Just provide the name model Pegasus. So it will automatically download the model in the pipeline. Okay. So now if I run the pipeline, now pipeline is being initialized. Okay, it has been initialized. Now what I need to do, I need to call my pipe. Okay, and inside pipe I need to provide my dialog. Okay, this is the dialog I need to provide. So what it will return? It will return one output. That means your summary. Okay, so let's store it in a variable called pipe out. Okay, and let's print it also at the last, because I want to see what it has generated. Now let's run it. So these are some warning, just ignore. Just wait for some time. See, it is predicting. Okay, it is generating the summary. Now see, it has generated the summary, but it is not readable, because here if you see /n is there, but it's not like printing the new line. Okay, for me. So there is one modification you can do. So what you are doing here, the summary text you are getting. Okay, I'm see pipe out, I'm calling the summary text. Okay, and I'm replacing this. See, this is the, like you can say, bracket n, okay, with the new line character. So now what it will do, it will just, whenever it will see this, I mean syntax, okay, it will replace with new line character and it will print as a new line. Okay, now let me show you. Now I think it is understandable, guys. Okay, now if you see, this is the summary of this entire dialogue. Got it? Okay, and if you see, if you just read it out and if you just see the summary, you will feel like it's not giving the good summary here, because here if you see this model, okay, so the data set they have used, see, they have mentioned, and here if you see, Samsung dataset is not present. Okay, they haven't used Samsung dataset, they have used other dataset. Okay, so that's why I need to do the fine tuning with my own data, with my custom data. I hope it is clear, guys. Just write something. Okay, now I told you, you can also check some like accuracy score. Okay, so let's check the accuracy, like how your model summarization model is performing. So for that, I need to use something called row metrics. Okay, row metrics. So just remember, if you're doing summarization task, to measure the summarization performance, you have row metrics. Okay, how it will work? So you need two functions for that. Let's create the function one by one. Okay, don't memorize the function, try to take it as a template. Okay, because this function will remain same everywhere. So this is one function you need. So what it will do, basically it will generate batch. Okay, so why batch is important? Can anybody tell me why this function is important? Just read the function name, I think you will get the idea. If you see, doc string is also there. Yeah, because I don't want to load entire data to my memory. Okay, so what I will do, I will pass my data batch wise. First of all, let's say I'll first of all give 124 example. Okay, it will calculate the matrix, it will save the matrix in a just one variable. Then again I will pass 124 example, again it will calculate the matrix, and it will sum up the matrix. Okay, so like that, it will loop through all the batches and it will take all the data I'm providing. Okay, then it will give me one final accuracy. Okay, that's how it works. Got it? Yeah, you are correct. Your memory might crash. Okay, now this is the calculate matrix function. Okay, so here you are not doing anything, you are providing your data set, you are providing the matrix. What is the matrix? Row matrix. Okay, row matrix. See, load matrix I have imported, if you remember here. Okay, load matrix. Inside load matrix, you just need to pass which matrix you want to use. Okay, for me, I want to use row matrix. I just define the name. Okay, it will automatically download the matrix. Okay, and you are passing this matrix inside this function. This function is taking some of the parameters: dataset, matrix, model, tokenizer, batch size, device, column text. Okay, which is your column text? It should be dialog. Column summary, it should be the summary. Okay, and first of all, what it is looping through, okay, all the batches, it is applying the tokenizer, because what I need to why I need to apply the tokenizer, because my data set, it is in text form. So first of all, I need to convert to them into like encoding. Okay, number representation, that is what it is doing. And how it is performing, I think you got it. I showed you, I think, in our NER session. Okay, how this tokenizer work and how it provide the outputs. I think you remember it will provide in input IDs, then mask IDs, okay, and it will give you the encoding, all the encoding. Okay, I think you remember. Then see model.generate. Now you are passing all the information like input IDs, attention mask, okay, you will give, and you are defining some penalty. Okay, what is the penalty? I think if you remember, this is the penalty. Like you want to generate some longer text or shorter text. Okay, so this is penalty you can set here. So by default, as a hyperparameter tune, they have set 0.9, sorry, 0.8. And these are some parameter you need to set. Okay, so once it is done, you are getting your like summaries and all, and it will provide the score. Okay, returning the score. That's it. Now let's execute. Just use it as a template. Okay, you don't have to memorize this one. Now if I run this one, so now see, I'm first of all initializing my row matrix, and I'm calling my this function calculate matrix, and this function is called inside that. Okay, inside this calculate matrix. Okay, here it will generate the batches. Okay, by your data set. So first of all, I'm passing my data set. First of all, I'm passing my test data set because I want to first of all see my model is performing good or not. So for that, I need to pass my test data set, because if you see my entire data, it has three section. Okay, three subsection. Like one is like training, testing, and validation. So training and validation I'll be using for my training, and testing I will be using for my testing purpose. Okay, so that's why I'm passing the testing data. Okay, row matrix, this one I'm passing. Okay, model Pegasus, which one I have, I think, assigned. If you see here, model Pegasus, see, I have already initialized model Pegasus. Okay, so this one I'm passing because I'm checking the accuracy. Okay, my with the pre-trained model, not my trained model. Okay, I'm checking the accuracy with my pre-trained model, not trained model. Just remember. Then tokenizer I'm passing. Column text, your dialog, that means this one would be your X. If I show you the data, this is your X data. And column summary. Okay, summary. So here if you see, this is the summary, this is your Y data. Okay, and batch size is 8 I'm passing. Okay, this size you can increase, decrease based on your machine configuration. Now if I run it, so basically it will take time. Okay, it will take time. So basically it will do 103 iteration. Okay, and again you have lots of data, it will take some time. So what I will do, I will interrupt the execution and I'll show you like how your accuracy will look like. Okay, because it will take a lots of time. For me it took around 20 to 30 minutes. Okay, always you get the code from Hugging Face. Okay, Hugging Face documentation, but there you need to do some modification based on your requirements. I did my own modification here. Okay, and I will share this code, just upload it in your GitHub. Okay, take it as like training notebook. Whenever you have something called summarization task, try to use the notebook. Just change your data there. Okay, it's completed. Now let's print out all the matrices. So row matrix has some of the, like you can say, matrix section. If you talk about like row 1, row 2 score, and row L score, and this one row L sum score. Okay, so these are 4 score you have inside row matrix. Okay, so first of all, what I am doing, I am looping through each and every matrices, and I am taking all the information in a dictionary, and that thing I'm converting to the pandas data frame. Okay, now if I run it, see, this is your row score. Okay, now if you ask me how to evaluate the like summarization model, this is the evaluation. Okay, this is the evaluation technique. Now you need to see here, accuracy is very less. Okay, row score is very less, it's 0.01. Why? Because this data set is very new to this model. Okay, so now actually we'll be training our own using our own custom data, and after that whenever I'll be printing this score again, you will see this score will be increasing. Okay, so that's actually you can evaluate, okay, any model before training your own model. Okay, this part I think it is clear, guys. Yes or no? Just write yes or no. Okay. Now, what I will do, I will convert each and every, because if I show you my data here, uh, let me show my data, because I haven't converted my data in a numerical representation yet. Okay, first of all, I need to convert them all. So if I show you the data, so this is my data. So first of all, if I show you this one train, it will give me the training. If I show you the first one, so it is still like, I mean, text representation. Okay, first of all, I need to convert it to like tokenization, then I need to convert to the encoding. Okay, that means you can talk about what embedding I need to apply. Okay, so let's do it. So this is the function. It will basically convert your all the example to the features. Okay, that means the numerical representation. The same thing I am doing. I'm calling my tokenizer. Inside tokenizer, I'm passing, first of all, I'm doing it for dialogue. Okay, this thing doing for dialogue. Okay, then once dialogue is done, max length I'm providing 1024. Okay, like max length, what are the max, I mean, which is the max length of your data inside that. Okay, it is 124. How you can get the max length? So you can test it like that. So this two code you can run, it will give you the max length of your. Okay, it's not for max length. I think it is unique tokenizer. Okay, but if you see, if you read the dataset somewhere, you will get the max length you will get. Okay, and you can assume the number also. It's not like that you need to provide 1024. Okay, you can give higher number also, lower number also, but most of the time I saw like people give this number. Okay, instead of taking all the, you can say, length and everything. Then once it is done, so I'm applying for my summary also. Okay, this is the summary data summary. So it will uh, represent my data as a numerical form. And from that, what I need input IDs, attention mask, and my labels. Okay, label is nothing but this one. Okay, so once it is done, it will map to your entire data set. Okay, which is your data set Samsung. And there is a map function. You need to call this function. Okay, and basically it will apply on top of all the data you have. It will convert all the data to numerical representation. Okay, now let's run. Okay, it's done. Now if you see your dataset Samsung PT, okay, let's take the train. Okay, now if I show you the first example, now you'll see all the, see, it has been represented as numerical. Okay, got it, guys? I think this thing we have also did in our NER, and I think I have also explained there. Now, if you remember, there is something called data collator. Okay, data collator. So you need to also define data collator. It will do some of the augmentation or batching. Okay, this will apply. It takes your tokenizer, okay, and model. So let's define. Okay, it's done. Now, what I will do, I will define my training arguments. I think you remember. Before starting training, we need to set some of the arguments. Okay, like what should be your output directory? Suppose, first of all, whenever you will start the training, it will create this folder. Okay, you can give any name here. 8 lines of code at one time. How to enter 8 lines of code one time means? Narayana. What you want to like tell me? I didn't get your question. Okay, so it will create this folder. Inside this folder, it will save all the checkpoints. Okay, all the metadata of your training. Number of training epochs I have set as 1 because again it will take time. Warm startup steps, it's 500. Okay, it's like a hyperparameter. Then this one batch size, then device batch size, weight decay, logging step. Okay, evaluation step. So every steps like this thing you can set is as default, but only need to change this number of epochs. Okay, the epochs you want to train. But for me, I will just keep 1 because it will take a lot of time. Okay, to train the model. Now let's run it. So it will save all the arguments. Okay, now I will call my trainer. See, every task, this thing will be remain same. Okay, it's not will change. If you see your NER also, this thing will remain same. So your trainer will take your model, tokenizer, data collator, training data set, which is nothing but our train, and your evaluation, which is nothing but your validation. Okay, now let's run it. Now again, it won't start the training unless and until you are not calling this one trainer dot train. Okay, now if I execute this one, now you'll see it will start the training. Again, it will take time. So what I will do, I will stop the execution, and I already saved the model. Okay, I already trained the model and I already saved it. Okay, let me show you. I think it is visible, guys. Okay, so this model I already trained and saved here. See, this is my PyTorch model bin, and this is the configuration. I will show you like how to save it, but I already saved it because it will take a lots of time. Okay, around almost 14 minutes, 40 minutes it will take. Okay, so let's stop the execution. For you just train the model. Okay, you just train the model, just let it finish. Okay, so once it is trained, what you need to do, again you can calculate the row score. Okay, using the same code. Now let me show you my previous notebook. Okay, see, I have done the training. I think this notebook is visible, guys. The new notebook I just kept here. Okay, see, it was the training. Okay, this is my steps, training loss, validation loss. Okay, although it's like very high because I trained just 1 epochs and it took 40 minutes. Okay, to train. Then I again calculated the row score, and if you see, this row score is increasing. Okay, then you're like before score, if you see. So if you are training like with higher number of epochs, around 100 epoch, 100 and 200 epochs, you will see it will be like increasing very much. Okay, then you need to save your model. Okay, saving the model, this is the code you need to write, model Pegasus, because you have defined your model like that. Save pretend. Okay, and just give any name. Okay, any name you want to save. So I given this name. So if I show you my drive, so it will create one folder, and inside that folder it will save all your model. Okay, once it is done, you need to save also tokenizer, this tokenizer. Okay, the tokenizer you have initialized. So again, call save pretrain, give the name of the token, like give any name. So it will create another folder called tokenizer. Let me show you here, and inside it will save all your tokenization information. Okay, this thing you just need to do. So once it is done, now let's load our model. Okay, in this notebook, because this one I already saved all the model and my tokenizer. Okay, I'm not training because it will take time. So now let's do the inferencing using our train model. Okay, so first of all, what you need to do, you need to mount your drive, because this model is presented inside my drive. So let's mount first of all. Now if I refresh here, I think it has been mounted. It will take some time because in this drive, actually, there are too many sub files. Okay. So again, what I will do, I will change my directory to this location. I have all my information. So basically I'm changing the directory, doing cd, and I'm just coming inside this folder. Okay. FSDS November 10 a.m. And inside that I have all my models and tokenizer. Okay. So now if I just execute, okay, they're giving some warning. It may take some time because inside drive I have so many of files, so that's why. Okay, so see, it's downloaded. Now if you just write pwd, you will see we're inside this location. Now if you just write ls, you can see all my tokenizer and my load pretend models. Okay, see, this is my saved model and this is my tokenizer. So these two things I need to load. So now to load that, what you need to do, you need to call the same auto tokenizer. I think you remember you have imported. Just call the pretend and give the name of the folder. Okay, tokenizer. I'm just giving. Now let's load. See, it will load. Okay, it's loading your custom tokenizer, whichever you have trained right now. Okay, now what you need to do, you need to load your model, but I will load my model in my pipeline. Okay, so first of all, what I need to do, I need to take, let me first of all take one testing data from my dataset. This is the dataset. I have entered dataset. Now I will take some test information. So first of all, I'm taking dialog, okay, and summary, okay, as a reference. Now if I show you the dialog, it looks like that. This is the dialog, entire dialog, okay, and the actual summary of this dialog, which is this one. Okay, now let's see how my model predicts. Okay, so this is the code for that. Okay, now I will explain this one. Just focus on this one. Okay, first of all, the same thing I'm doing, I'm calling the pipeline. Inside I'm mentioning the task I want to perform. I want to perform summarization and model I want to use. Okay, now which model I want to use? Okay, because previously I was using this model, if you remember. I think here my Google Pegasus model, I think you remember. Okay, but here I have trained my own model. Okay, so the model folder name is here. If I do ls here, so this is the name I saved. Okay, I will just give this name, this folder path I will just give. Okay, and tokenizer, this tokenizer I imported here. Where? Yeah, here, this tokenizer I'm passing. That's it. Okay, now let's execute. And what is this gen keywords? Okay, length penalty 0.8. Okay, and number of beams, this thing you just keep it as same, but this thing you can change it. Okay, length penalty, just relate like that. Okay, if you need some longer length, okay, of your summarization, increase the value. That means this value, length penalty. And if you need some lower, okay, like shorter information, let me show you. Text is already summarized. Okay, so let me decrease, re-summarize. See, it's giving some shorter text. Okay, but if I increase the length and if I re-summarize it again, okay, it's not doing. Let's refresh. Let me copy some of the text from here. Let me paste. If I increase the length, okay, now if I do the summarize, okay, you will see it will give you like longer, okay, with respect to your text. So this is the your penalty. I think you got it now, like how this thing is happening in this UI. It is clear, guys? What is like length penalty? Yes or no? I am like relating with the actual application. Okay, just try to understand why this thing they have kept here. Okay, but before you had confusion like what is this summary length, but I think you got it. What is summary length? Okay, how to save it? Okay, now let's call my actual, first of all, let me show you my actual dialogue and summary, because I have already imported here. If you see sample text and reference, let's print it. Okay, this is the dialogue, this is the summary. Now let's see how my model predicts. Okay, so this is the code. So here I'm calling by pipe. Okay, inside pipe I'm passing my sample text, which is nothing but this one. This is the dialogue, and this gen cargs. Okay, whichever I have initialized here. This thing you need to, I think you have learned k works and args in Python, guys. Star k args and args in Python, I think you have learned. Okay, so this thing actually it's working. So you need to pass as arguments. So gen args, okay, and it will give you what? It will give you summary text. So that thing I'm extracting just. Okay, now let's run it. So this is the model summary we'll get right now. Let's see how it predicts. See, now if you just read this one, this is your actual, this is your human annotated, this is generated by your model. And if you read the dialogue and if you read this summary, you will feel like, okay, it is almost good. But again, I have trained one epochs. You will feel like not that much of good, but again, it will generate something for you. Okay, I think it is clear, guys, this text summarization. Okay, now what you need to do, you have the model. Okay, download the model, download the tokenizer. Okay, try to load like that. I showed you loading. Okay, how to load. Okay, load like that. See, epochs, again, it depends upon the task, and I don't know, like training, how I can say like how many epochs it needs, but at least set 100, 200 epochs and see like whether loss is decreasing or not, whether accuracy is increasing or not. Okay, in every epochs. If it is not doing, then stop the execution. Okay, you need to track that. There is no fixed rule like that much of epochs you need to set. Okay, if you had good configuration, PC, keep it 1000. We have used Samsung dataset. Will it? See, dataset is nothing but it's just a take. If you just relate with the pandas data frame, okay. See, but the loading you are doing there, it's a different way. They're giving dictionary object. That's it. But same data, you need to prepare your data like that. Load the data. Try to apply tokenizer. The same thing it will do. Okay. But why I'm using Hugging Face data? Because it is already labeled data. Okay, because if you see text data labeled is like very hectic task. Okay, that's why. No prediction of other like food summary. Yes, see, the data you will be using, only that related summarization you will get. It is only specific for conversational. Okay, if you see the data, it is conversational data they have mentioned. Okay, some data messenger like conversation. If you want to use food summary, you can use some food conversation data there. Got it? That's why you have different data set here. If you see data, okay. Now, if you want to do suppose summarization, select summarization, English data you need, okay. And here you see there are lots of data, okay. If you want to perform from on news, okay, news is also there. I think food is also there. I think somewhere you can filter by name. Let's give food. Okay, food is not there. Like, let me remove. I think food data set is not there. Okay, instead of food, you will get all the data. They haven't added food data. See, Amazon review is also there. Like many data. If you want to read about the data, what is data, just click here and you will get the summary of the data and each and everything. No, I think you got confused, guys. Pegasus is a model. Pegasus is a transformer based model. Okay, BART is also transformer based model. It's like your VGC16 and ResNet. Got it? Different architecture. Yes, I'm sharing the original notebook. Okay. See, Pegasus, the model I have used, this is one of the like variant of transformer model. Okay. BART is another variant of the transformer model. GPT is another variant of the transformer model. Always remember. Got it? I'm sharing the actual notebook, which has all the comments and everything. Okay, although I will share it. Yes, it is built on your actual transformer you have learned, which is attention is all you need paper. No, not randomly. Calm hugging face. Click on the model. Okay. Just try to see like how I'm selecting the model. Click on the model. Which task you want to perform? Tell me. Just look here which task you want to perform, guys. Summarization. Click on the summarization. Which framework you would like to use? PyTorch or TensorFlow or JAX? PyTorch. Click here. Which dataset you want to select specifically? Otherwise, just keep it all. Okay. Language. Which language you want to work on? Let's select English. These are the model, around 160 model you have for summarization. You can select any of the model. Okay. But I used Pegasus model, Google Pegasus model. Got it? See, Pegasus has like different version. Pegasus X sum is also there. Pegasus large is there. Pegasus large X sum is there. Okay, but I use this one. Pegasus CNN, I think somewhere I think you will get here. You can search here. Got it, guys? It is clear how to select model. Based on the task, you need to select model. Okay. And again, if you see, there are parameter size. Okay. 1.12 million parameters. You will use that? Tell me. Okay. You will go through some smaller model. Yes, you can select any, but again, see the parameter size. Okay. It's not like blindly you will be selecting any model which has 1.12 million parameter. Just let me know what kinds of machine you need. You need 3090 RTX. Okay, guys, I think it is done from my side. Thanks for joining the session.